So, good morning. We can start our webinar. So, today we are going to take webinar on the topic interpolation in ArcGIS Pro. So, we will start the webinar by giving a small introduction on the topic interpolation. So, interpolation in ArcGIS Pro is a process of estimating unknown values at unsampled location based on the known value from surrounding location. And it is commonly used in geographic information system for creating a continuous surface from a discrete data points. So these surfaces are very valuable for the analysis of elevation, temperature, precipitation, etc. And the basic of interpolation is data input. That is, interpolation start with a point data, and for example, the data that has been collected from weather stations, and these points must have a spatial locations like XY coordinate and also an associated values like temperature and elevation. So I have given an example of data input which include year, lat, long as well as the annual value. Annual, it is a temperature. It's a data of temperature, so annual temperature of the year 2000. And 1 minute. So once the interpolation method is selected, it means that the interpolation has different methods, that is IDW, Kriging, Spline, Topo to raster, etc. So once the interpolation method is selected, the result is a continuous surface, often as a raster, that represents the estimated value across an area, helping to visualize a pattern or predict condition at unmeasured location. So here there is an example. We have a point, discrete points as seen in the screen, and by interpolating we get a continuous surfaces, often referred as raster. And so next is the importance of interpolation in ArcGIS Pro. So its important is that it predict value from unmeasured locations and also help to create a continuous surfaces, and it improving decision making. For example, by understanding a spatial distribution of phenomena like pollution level, groundwater depth, a decision maker can make informed choices in areas like land use planning, disaster responses, and natural resource management. And it also helps to visualize a complex data. That is, it allows for a creation of easily interpretable surfaces which can be visualized in maps and 3D model, helps with communication and reporting. Am I audible? Can you hear me?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Okay. So I have given a small introduction part. So next we will be so in this introduction part I have covered the basics and importance of interpolation in ArcGIS Pro. Next we will go into the IDW, the one of the method of interpolation, that is inverse distance weighting, IDW. So it is a interpolation method that estimate value based on distance from non-data point. Closer a non-point is to location where you want to predict a value, the more influence it has. So in the IDW, we use non-data points, and we predict the value of unknown areas. So for example, if you have a temperature data point of different location, you want to predict the temperature in an area with no data, we can use this IDW method to predict that. So, and I will directly go into the workflow of IDW, how we can how we can do this IDW in ArcGIS Pro. So we can start that part. So this is ArcGIS Pro. So first I will add the study area. So I'm choosing Kerala as my study area. So here, so we already discussed that we need a data input, that is a point feature for this interpolation. So we'll first, we'll add a data. Uh, the data is in CSV file. So this is the data. So before starting IDW, I will let you know how I downloaded the data. So for this, I choose Power NASA Power. So let's see how we are able to download the data from NASA Power. I hope you are getting my screen, able to see my screen. Okay. So this is the website, this NASA Power. From here, we can click on the regional. Here we can give select community. So I choose renewable energy and select a temporal average. So I choosing monthly and annual, and we can give select a particular. We can from this you can hear whether we can give a latitude, longitude, or otherwise there is a rectangle sketch tool. Just click on that, and we can from this map we can select an area. We can select a particular area and give the time extent. Like I have given from 2000 to 2020, and here the parameters is there. A lot of parameters. The NASA Power is providing a lot of parameters like all sky surface and the temperature, precipitation, etc. We can, according to our need, we can select. So I just giving a temperature 2 meters. Then the format is there. CSV, AC, CIE, NetCDF, different format is there. Just select one format and give submit. The data will be directly downloaded. In this way, we are downloading the data, and so the data I have is filtered one. Uh, this not my data. So this data, I will open this data. So I have filtered the data into specific year that which I need. That is from 2000 to 2020, in which we have lat long. It must be in mind that for doing interpolation, we need latitude and longitude of the area, and it's important. Otherwise, we will not be able to do the process. So, we have already added the data. So also the study area I have added. So next is we need to create an XY table for this data. So that means that we need to, these are only, we already have the data, CSV, it is in CSV file. So we need to create this data into point, that is point shape file. So for that, I am taking in the geoprocessing tool, XY table to point is there. So in the data management tool, we can find this. So XY table to points, give the input. This is my input, and say give the output. So the X field is longitude 2000, latitude is there, coordinate system GCCS, WGS 1984, and give run. So we have created points for the year 2000. In the same way, we can create we can create shape file for the other years. Um, So we have created shapefile, point shapefile for each year 2000, 2010, and 2020. So
Actually, it is showing error. Why it is shows error?
that's it.
It is showing error, no? The output feature class. Why? That 2020 dot shape file is it is showing error.
Wait 1 minute. No, it's coming. No, wait. I will do once more. It's not showing any error. It's coming. It's correct. Hello.
Okay, okay, fine, okay, fine.
So we have created points for each year. Then next is that, so this the points are outside our study area, right? So we need only the points within the study area, that is within the Kerala. So what we will do is we will batch clip. We'll clip this. It means that we will clip the points within the study area. For that we use clip. So in the analysis tool, we have an option clip. Right click on the clip. There is an option called batch. So why we are using for by using this option, we will be able to clip batch wise. I will okay. So we have click on the batch clip. So here batch input feature or data set. So here we can give 2000, 2010, and 2020, add, and which feature to be clipped, that we have clip feature we give Canva, and giving output as clip save. So I think that you understand why I selected batch clip. So in batch clip will be able to clip as a we will be able to clip the 2000, 2010, and 20 data together. So it will be much more easy than separately clipping the data. So I am giving run. So we have clipped the data. So now we have only the points in the study area. So the batch clip part is also completed. Next is the main part, that is we will be going to do IDW. So IDW. So so in the spatial analyst tool, in the interpolation we have IDW. We are selecting this part. Okay. So first we have to give input point feature, that will be clip, and z value is annual temperature, that is annual 2000. Then output raster, annual, 1000. Okay. Then power 2, search radius variable. Then next we are giving environment, the output coordinate system, WGS 1984, and we are giving the extent Kerala, and mask also. So we have given the extent how up to which we need interpolation, and also area to be masked, and we will give run. So we got the result. So this is the interpolated data of year 2000. We can change the symbology.
Hello. Hello. Excuse me. Hello.
Yes.
Nazar, actually, I just want to know that we have created a interpolated map now by means of that IDW method. So basically, this is for example only, or this may be a real data also.
It's a real world application. I have
You
the,
are just.
hello.
Yeah.
I
Yeah. Tell me. Yeah, actually, what happens is actually we did work on that soil data actually. So in that we have to make a 1 by 1 meter ka, that grid, and after that we can create such kind of maps actually. 1 by 1 means ki 1 kilometer by 1 kilometer.
Actually, I'm not getting. I don't
Okay.
understand
Yes,
well.
yes. Hello, sir. It is possible. You can give the boundary based on
Yeah.
you are talking about 1 mile by 1 mile. Then we
Yeah.
can create a boundary.
Yeah.
Using that, we can cut it based on that clipping. You can clip it. That is
Yeah.
possible.
So actually, what happens is we have to create a grid, and after that, because what happens is otherwise it will take the point which is not in use actually. Getting my point?
Yes,
So
yes.
it may be
For
so.
that, you have to give the boundary. Boundary. Yes, from where you want to give. No? Yeah,
Yeah.
that's why you are giving the input as a lat long. Yes, yes.
Yeah. So anyway, no issue. I can understand the IDW method through this. That is okay.
Okay.
No issue.
Now,
Okay.
what is your question? What is your doubt?
No, no. Actually, what happens is if we are creating, you have taken the points.
Okay.
That points are well distributed. Fine. Suppose I think the distance is fixed. Suppose 100 kilometers, because Kerala is a huge state actually. Means not that much, but yes. So it is a very much huge area actually, you can say. And we are
Yeah,
taking
yeah.
the point. Yeah, we are taking the point. 6 or 7 is coming into this picture actually. If you will see this example, so there are.
Okay. Well,
So
I think
that
you are doubt about the accuracy level about.
exactly.
About
That's
accuracy
what.
level? Yes, yes.
So we have to reduce the area or distance between the point actually. That may be 100 1 kilometer or something like that. So maybe we can generate the accurate. Yeah.
Yes. I think I understood what you are trying to ask. Yes.
Yeah.
So you have to go for the accuracy data. Not this is for sampling data only.
Okay. That is for
So you have
example.
to
That's
look
what
for
I'm.
the 1 meter accuracy level data. You have to
Yes.
download the accuracy level data. Then you can clip it according to your
Exactly.
specification or according to your
Exactly.
requirements. Yes.
Exactly, because we did that thing, and that point was not well distributed. They have taken that random sample. So in that, what happens is the data, the accuracy was very less actually.
Very less accuracy. Might be you
Yeah.
have.
So this is the
Okay.
right method. I think I have learned from you that. That's why.
Okay.
Okay. Thank you.
So we have created interpolation for year 2000. So next we will create for 2010. Same way we have done what we have done for 2000. It's the same way we are doing for 2010. So we have created interpolation data for 3 year 2000, 2010 and 2020. Okay, next we will create a map layout. Please give me a 5 minutes. 1 minute. I will create a layout. So next we will create a map layout for this. Okay. I hope everyone is able to see what I am doing. So this is the final out of interpolation using IDW, and we will add one more thing, that is grid. Now we have got the final output of what we have done. Okay, so this interpolation can be used in different fields like geology, mining, environmental science, etc. And other fields like pollution, hydrology, agriculture, etc. So other than this, there are other two methods, that is Kriging and also Spline. And we mainly focus on IDW only, but there's other method also. So I hope you understand what I have taken. So in conclusion, we can say that this interpolation method is very important method for I already tell the application, that is in geology, mining, everything, everywhere we can use this method. That's all from me. Thank you.